Transformer is operating at 12.5 watts. Okay, so power in is equal to power out is equal to 12.5 watts. All right. It steps 110 volts down to 9.6 volts. All right. Okay, so let's see. V primary is equal to 110. V secondary is equal to 9.6. These are volts. Okay, let's see. 320 primary windings, so NP is equal to 320. And then how many secondary windings are there? We could figure that out, right? And then what's the current in the primary and the secondary? Okay. We could do these asynchronously. Let's find NS first. All right, so we're going to go VP over VS is NP over NS. So 110 over 9.6 is equal to 320 over NS. All right, so 320 times 9.6. I'm just cross multiplying is the devilry I'm doing here, divided by 110. And I get 27.927. 27.927 windings. And I always get kids to say, well, aren't windings an integer? Not necessarily, right? You could wind something. Here's this thing, right? I can go around once. Now I've gone around 1.5 times. Now I've gone around 1.75 times. Now I've gone around 2 times. Now I've gone around 2.1 times. So it's a real number. Windings are a real number. Anyway, okay. So there's our number of windings, right? Okay. To be sure that probably on real transformers there are integers though, right? Okay, so what is the current in the primary and the secondary? Well, we just use this, right? Okay, so let's do the primary, right? Okay, power is IV. So 12.5 equals 100 I times 110 volts, right? This is watts, this is volts. So in the primary, we just use that. So 12.5 divided by 110 is equal to 0.1136. Right, so what is that? That's yeah. I guess 0.11 amps, right? We only have 2 sig figs, right? I hate sig figs. I don't like them. There we go. All right, here we go. Okay, so now let's look at the secondary. Okay. Okay, power is IV. So 12.5 is equal to I times 9.6 volts, right? Because there's 9.6 volts. All right, here we go. So 12.5 divided by 9.6 is 1.302. Okay. Now, a lot of kids always think, gee, you know, so little current is going in and so much current is going out. Doesn't that violate conservation of charge? Okay, and it doesn't. Okay, because here's why. Let me just show you this. Okay, so here's your core, right? Here's your primary. Here's your secondary, right? Okay, I can basically the current here might be 3 coulombs per second, right? Just pumping around in here, right? That's fine. We haven't violated conservation energy. That 3 coulombs per second is causing 200 coulombs per second to flow around this closed loop. There's no problem there. This 300 coulombs per second is flowing in this closed loop, and 3 coulombs per second is flowing in this loop. There's no problem with that. Charge is still conserved. All right.